So let's welcome North Carolina School of Science and Mathematics, Team 7412. So the first question is the easiest one. Would you tell us your name and what year you are in school? And then the judges will introduce themselves and the competition will begin.
So my name is Sunwoo Yim and I'm a senior.
My name is Vineet Ranjan. I'm also a senior.
My name is Simon Marland, and I'm a senior.
My name is Kelly Zhang, and I'm also a senior.
My name is Catherine Yang, and I'm also a senior. Is my mic working? Okay.
I'm Karen Bliss from Virginia Military Institute. This is Dan Connors from IBM and Ben Galuso from Shippensburg University. You're going to have 15 minutes for your presentation. I'll let you know when you've got 2 minutes remaining. I'll kind of give you a signal so you'll know. After that, there'll be about 5 minutes of questions, and then we'll be done. So please begin.
Good morning, everyone. As we all know, sharing is caring, so let's talk about car sharing. So car sharing is a plan where multiple people will use the same car as an alternative to private ownership of a car. In other words, more than one person will use and drive the same car, as opposed to one person owning and operating their own vehicle. Car sharing decreases traffic, pollution, as well as costs, so you can see why US drivers are increasingly switching from private ownership to car sharing plans. And because this industry is still new and still continues to grow, companies want to investigate different cities and different car sharing plans and determine what their best strategy is in moving forward. The problem we were presented with was first to characterize current US drivers as having low, medium, and high driving distances and driving times. Then we considered 4 different car sharing plans as well as 4 different cities and determined what the best strategy for a company would be. Next, we considered the same problem, but this time implementing self-driving cars as well as green energy and determined whether these factors changed a company's strategy. So the 4 different car sharing plans we looked at were round-trip car sharing, one-way floating car sharing, one-way station car sharing, and fractional ownership. In round-trip car sharing, a driver will pick up a car at a station, drive it around, and then return it to the same station where they rented the car in the first place. In one-way floating car sharing, a driver will pick up a car, drive it around, and then leave it wherever they want. In other words, the starting and ending locations do not matter because the driver can pick up the car and leave it wherever they desire. In one-way station car sharing, a driver will pick up a car at a station owned by the company, drive it around, and has to drop it off at a station owned by the same company. So in essence, the car's trip goes from one station to another, and the car is limited in where it can drive because it has to be dropped off next to a station. And lastly, in fractional ownership, multiple people will use and operate the same car. So one car will be owned and driven by different people, either through carpooling or they will coordinate with each other to share the same car and lower the costs and fees for each of them. And the 4 different cities we considered were Poughkeepsie, New York, Richmond, Virginia, Riverside, California, as well as Knoxville, Tennessee. Next, Kelly will come up to discuss part 1 of the problem.
In part 1, we examined 2 different considerations, driving distance and driving time, and split US drivers into 3 categories, low, medium, and high for each of the considerations, resulting in 9 different characterizations of US drivers. Using data from the AAA American Driving Survey, we developed an implicit method to characterize US drivers. Given with this data were the values that were significant at the 95% confidence interval. The values highlighted in blue are those that were lower than the 95% confidence interval, and highlighted in red are those that were above the 95% confidence interval. But as you can see, all the cells that are highlighted in the distance column are also highlighted in the time column, leading us to believe there's some correlation between time and distance. And this was confirmed using the linear fit of time over distance. And that makes sense because when you're driving, you have a starting point and an ending point with a fairly fixed distance. It's only the time between those two that varies. So now we want to figure out our distance categories based on our time categories based on our distance categories. So combining all the blue cells, which were below the 95% confidence interval, as our low distance category, the 2 white as our medium, and the red as our high, we want to figure out what our time categories will look like. So we did this by using two pieces of information, the fraction of US drivers in each of the distance categories, and also a pseudo speed, which will act as a conversion factor. So by using the number of US drivers in the column on the right, we found the fraction of US drivers in the low category to be around 22%. For the pseudo speed, we calculated the weighted average of distance and the weighted average of times for each of the age ranges, for each category using the age ranges provided. So for low, that was around 0.59. Now, dividing the fraction of US drivers in each of the distance categories by the corresponding pseudo speeds, we can figure out an unweighted form of the fraction of US drivers in each of the time categories. So for low, this is around 0.36. Now, normalizing these, that changes to around 0.23, and multiplying entries in the distance consideration and the time consideration, we can actually find the percentages of US drivers in each of the 9 different characterizations. So for low driving distance and low driving time, that's around 5%. And all these numbers are in this table shown here, and those highlighted in yellow were the ones we wanted to target with our car sharing driving plans. But what if we had more data? We could not find data like this when we were actually doing the competition, but if we did, we could use the mean and standard deviation to estimate the data using a normal curve and fit normal curves underneath this to represent the low, medium, and high for each of the categories. And that would help us find strict bounds for these in a more explicit way of defining our 9 characterizations. So doing this for time and distance would be very helpful and also help define our characterizations. Now Simon will come up and talk about part 2.
So in part 2, what we wanted to do was develop a model to compare the 4 car sharing plans and the 4 cities. We had to assume a couple things. First, that the day-to-day cost of owning a car, driving a car, paying for gas, that sort of thing, did not affect the model. Secondly, fractional ownership is just between 2 people to make it a little bit simpler. And thirdly, and most importantly, people have to make logical choices based on their cost-benefit evaluation of their situation. The first thing we noticed was that round-trip car sharing is not really feasible for commuters. It's much more geared towards people that may be flying into a city and then driving around. Their price plan is much more suitable for longer periods of time. So what we did was we ranked the cities for round-trip car sharing based on information about airports. And we found that Richmond, Virginia would be the most beneficial city to start a round-trip car sharing company in. Next, we developed a model to compare the other 3 methods. This is fractional ownership, point-to-point, and station, I believe. We made an agent-based model in NetLogo where basically each commuter drives from a residential area to a commercial area, and this is, you can input the driving time for each city, and there's information about this in the urban scorecard. This is given by Texas University of Austin. And so each one will drive from the residential area to the commercial area and take the time it takes to get there and how long it takes and information like that to decide which car sharing plan is best for them. And then we output that and compare the cities and the car sharing plans. Next, Vineet will come to talk about the metrics we used, the cost plans we used, and the results of this model.
Okay. So as Simon discussed, we used specific metrics in our NetLogo model for the agents to make their specific choices. So the cost functions that we used for the floating, station, and fractional ownership models are shown here. And these are based off of cost calculations from Uber, Zipcar, and the national AAA reported averages, respectively. And so we modified them a little bit for our purposes in our model, and then we created what we call a ranking function. This ranking function takes a randomly generated value S, which is a scalar for whether the agents prefer to save money or prefer to save time. And then by ranking each of the 3 models or strategies, the agents were able to make their choices as to which was most beneficial for them. And this was how we garnered the most participation of the 3 models. So here are the results for participation. And we see there is an enormous preference for fractional ownership. And if we think of why this would be true, we can see that in a fractional ownership system, it makes sense that the two people that own the car can work together to figure out a schedule and figure out availability of the car, and so that makes time a much less issue for these people. And then we have the one-way station, the one-way floating models. But the issue with this is that a car sharing company really has no interest in fractional ownership by nature of the practice. And that's because fractional ownership is really just selling off the cars, whereas a car sharing company wants to keep rotating them out. And so really this is more of a car dealership type of strategy. So the best option for a car sharing company, we decided, was to proceed with the one-way station model. And so we implemented those specific cost functions from the real car sharing companies into our agent-based model, as well as the parameters for each of the 4 different cities to determine the company's profit for each of the specific cities. And that's how we got these results. And so as you can see, the average profit per capita was highest in Knoxville, Tennessee, which means that that would be the best city for a car sharing company under the one-way station model to implement their strategies. The bars represent the 95% confidence intervals using standard error calculations, and that's because we ran the model multiple times, and we ranked them by their means. For the other 3 cities, because of the overlap in the confidence intervals, we can't make a statistically significant claim about these 3, but we can about Knoxville, Tennessee, because it is higher than the rest. And so now Sunwoo will talk about part 3 and our strengths and weaknesses of our model.
So in part 3, we considered the addition of self-driving cars and green energy. And one key simplification that we can make is that the addition of self-driving cars removes the need for humans to go to a specific location to pick up a vehicle. And so when we reflected this simplification into our model, we found that we could combine the one-way floating strategy and the one-way station strategy. And then we modified the cost functions to remove the human driving service component of the cost. So we reran the model after modifying the model, and we found the following data. And so what you'll notice, first off, is that similar to part 2, Knoxville is the city that's most profitable, and thus the one that the company should pursue its self-driving car plan in. For the other 3 cities, the relative rankings have shifted slightly. Richmond has gone from 3rd to 2nd place. However, the difference is not very significant. So let's talk about our model itself. Well, the data is skewed a little to the right, and this is because it's based off of averages. The AAA reports that the average daily driving time is 46 minutes and the median is 22 minutes. Also, specific city layouts are not accounted for. So in real life, you would expect to see different parts of the city more densely populated than others, and therefore the traffic to vary across the city. However, our model assumed a uniform distribution of traffic. Lastly, because of the availability of our data, the boundaries between the low, medium, and high intervals are not exact. And we had to determine them using the 95% confidence intervals. So for our model strengths, first off, our model is very robust, and we can show this through our sensitivity analysis. And one interesting aspect of the sensitivity analysis is that when we increased the time spent waiting for a vehicle, we found that individuals shifted which option they pursued. And so this is reassuring for us because in real life, you would expect for individuals to choose different car sharing options if the time spent waiting for that vehicle increased. In addition, our model is very easily applicable to other cities. And so let's say that in our problem, we wanted to add a different city or change a city. Then we could easily do this by finding this input values for that specific city and then putting that into our model and then rerunning the model. Lastly, our model is agent-based, and this provides some unique advantages over other deterministic models. And this is because the decisions of each individual contribute to the overall outcome of the whole. And so this more closely simulates the real-life complex system that is car sharing. So we'd like to acknowledge Dr. Teague, our teacher and coach, Ms. Graves, our chaperone, the Moody's Foundation, and SIAM. So here are a few notable references, and are there any questions?
All right, thanks, you guys. I do have a question, right? You expect that, though.
Yes.
So I was wondering, this is something that you shared with us today, and that was a little bit different from the paper, is you had a couple iterations for question 1 that you had first done. I just had a question on how did the second iteration, or did it evolve from iteration 1, and were there things learned from that? And so going forward, what was your overall outcome when you compare those 2 models?
So this was for part one.
For part one,
Oh, wait.
right? Do you know what I'm
Yes.
referring to?
So
Okay.
in the beginning, we first categorized them just by whether they were below or above the 95% confidence interval. And I just really didn't like how that looked, because if you look at the table 3 on page 4, that's very symmetric. And in real life, that doesn't make sense. Those numbers don't fit our prior knowledge of who drives what distance and what time. So then we realized that time does depend on distance when you're driving. So we wanted to factor in that pseudo speed and the conversion factor from distance to figure out our time.
And I think an important piece to note on that is that as iterations of models evolve, we use the same strategy of multiplying the adjacent or the corresponding columns, such as low time, high distance. But once we varied the values, we could use that same model from before, but with different parameters, and that gave the results.
Okay. All right. Because I was going to say, at the end of the day, you had that intuition, yet the results were not significantly.
not.
Like, hugely different, were they? Between the two?
The percentages didn't vary by
Right.
large amounts, but they did.
They did vary in the ways that you expected.
Yes.
Okay.
I wanted to ask a question about the fractional ownership. Can you put the graphs up here that had the big bars for fractional ownership? There you go. Okay, so I found it super interesting that you came up with fractional ownership was the number one thing that it looks like individual preference. And so a couple questions, one of which is that I don't know anyone who actually is involved in fractional ownership, even though it is something that you're indicating would be something that everyone would like to choose. So I'll be interested to hear what you think. Is that because I'm old? And your generation is more interested in that. And then the second question I would have is, so given that there is this big preference for fractional ownership according to your model, if I'm a car sharing company and I'm ready to move into some city and open up, do I need to be concerned about that? Is it maybe I shouldn't move into any city, or yeah?
Okay, so the thing about fractional ownership is, firstly, car dealerships don't really encourage it because they make more money if they sell a car to every person instead of selling it to a group of people. So it's not very widespread just because it's not marketed. And there is also a factor that would make it a little bit inconvenient. If you're not going the same place as the people you're sharing the car with, then you won't have the car. So that might be why that's probably why it's not very prevalent. I would say it's probably going to get bigger because it is a lot more convenient, assuming that you set it up in a way that you're going the same place as the other people that own the car. And the thing is that the other two options shown here, the models we used are competitive with single person car ownership. They're not made to be competitive with dual person car ownership. So if you put single person car ownership on there, all the bars would be a lot closer because of the costs associated with one person owning a car.
And I'd like to point out that in real life, we do kind of see a little bit of fractional ownership more than you might think, because although different families might not own the same car, we do see teenagers and parents sharing the same car. So that's also kind of a thing within the same family.
And I think the last reason that we might have seen this in our specific model is that third key assumption that Simon talked about with the logical decisions based on strict cost-benefit analysis. Because in real life, there are other factors. We didn't account for two people that argue over who gets a car. It's just we assume they work together well. And that's probably why we see such a huge spike in our model. But because of our own intuition, we could kind of take that out.
Thank you.
Could you have factored that in your agent-based model, that there would be competition for the car at the same time, an inconvenience factor and something like that?
We probably could have, but at that point in time, we didn't decide that would be enough of significance, especially once we saw these results. We probably just decided to go with the station model.
Yeah, and that's something that we could definitely add to later iterations of our model. But yeah, we didn't consider that at the time. Yeah.
to go along with that, there's also going to be competition inherent in the other car sharing policies. So for example, if you have a Zip car where you would go to a station, pick up a car and drive it to another station, there's going to be competition to get cars there, assuming that the company does not have a ridiculously large amount of cars everywhere, which would be expensive for them. So we would have to factor in the competition and wait time for if a lot of people are trying one option, that there would be a time cost associated with that also.
Picture means.
I think we're out of time, though.
Do we have
No.
time?
Unfortunately. All right.
Sorry.
Oh.
Thank
you so
Thank you
much.
so much for answering the question.
Thank you.
Thank you.